Intercepts. Intercepts are special points on a graph where it crosses the x or y axis. The x-intercept is the point or points where the graph crosses the x-axis. The y-intercept is the point or points where the graph crosses the y-axis. Let's find the x and y-intercepts of the graph below. First, the x-intercept is the point where the graph crosses the x-axis. So it is this point. The coordinates of the point are 1, 2, 3 on the x and 0 on the y. It has not moved up or down. Let's think about this x-axis in general. If any point is going to land on this x-axis, what is the y value? It will be 0. Let's find the y-intercept. The y-intercept lands on the y-axis, and so it is this point. And let's see about its coordinates. First of all, for the x value, to get to that point, you have not moved across. So the x coordinate is going to be 0, and the y is positive 2. Think about a y-intercept in general. To make it land on the y-axis, it has not moved across. So the x-coordinate will always be 0. Let's look at the x-intercept on this graph. There are actually two. Any place where it crosses the x-axis is an x-intercept. So here's one and another one. The coordinates for the one on the left, the x is -3, and it has not moved up or down. So the y part is 0. And for the other one, the x-coordinate is 3, and it has not moved up or down. So the y is 0. So you can have more than one x-intercept just depending on your graph. Any place it crosses the x-axis is an x-intercept. Let's look for the y-intercept on this graph, and there's only one right here. And its coordinates are 0 going across, so 0 for x, and -4 for the y. If we want to find the intercepts of an equation, we can do it algebraically. For the x-intercept, we will substitute 0 into y, and for the y-intercept, we will substitute 0 into x. So let's find the x-intercept first for this problem. And for the x-intercept, we have to substitute 0 into the y. And 5 times 0 is 0, so it cancels out. We have 2x equals 10, and divide out the 2. So x equals 5. If we want to write it as an ordered pair, the x we just found and the y we put in originally is 0. Now let's find the y-intercept. We will need to substitute 0 into the x. So 2 times 0 is 0. That piece cancels out. With -5y equals 10. Divide on both sides by -5 will give us y equals -2. To write it as an ordered pair, our x is 0 and the y is -2. So here are our intercepts. We can use the intercepts to draw the graph. If we use the intercepts, 2 points are enough because they have a built-in check. we know that they will land on the x or y axis by definition. Let's draw the graph of this equation using the intercepts which we found. So first, 5, 0, start at 0, 0, over 1, 2, 3, 4, 5, and up 0. X-intercept lands on the x-axis. Then we'll do the y-intercept. Start at 0, 0. It says don't go over, but go down 2. Make a point. Y-intercept lands on the y-axis. We'll connect the points to draw our graph. Let's look at this example. Find the x and y intercepts of the equation 2x plus 3y equals 9 and draw the graph. So we'll find the intercepts and we'll just go ahead and do it in a little table format. We know for the x-intercept, we let the y equal 0. And this piece will cancel out. So we have 2x equals 9, and we'll divide by 2. This one gives us a fraction. It will be easier to locate if we change over to a mixed number. So we'll divide 2 into 9. And we get 4.5. So we have 4.5 and 0. That gives our x-intercept. Then let's find the y-intercept. For the y-intercept, we'll put 0 into the x. So we go back to the original equation, except we're going to substitute 0 into the x. This piece cancels, so we have 3y equals 9. Divide out the 3, so we get y equals 3. Now we have two ordered pairs. We can draw the graph. So first, 4.5, 0. X-intercept should land on the x-axis. We're going to guess for 4.5 about right here, and it does not go up or down. And then 0, 3, y-intercept should land on the y-axis. We'll connect the points to draw our graph. Many times you are only asked to graph, but not told what technique to use. Using intercepts to graph is a good idea when x and y are on the same side of the equal sign. When you plug in 0, it will make a term cancel out and make it easy to solve for the other variable. Then you switch and plug 0 into the other variable to find the other intercept, and it will also make a term cancel out and make it easy to solve. Here are some examples on the left that will be easy to graph using intercepts. Notice all of these have x and y on the same side of the equal sign. These problems, if I was only asked to graph, I would not choose intercepts. The intercepts would take more work. A different method would be faster.